discuss about the second equation of motion. What's the second equation? S is equal to ut plus half at square. Okay. What it says here? It is the distance. And u is the initial velocity, a is the acceleration, t is the time. This second equation of motion is also known as position-time relation. Okay. Now let us derive the second equation of motion using the same graph. Okay. What is this graph? Velocity-time graph for uniform motion when the body is initially not at rest. That is, it is having an initial velocity u. So let us derive that. And can you see what is this figure here you are obtaining? See, this is O, A, B, C. That is the figure you are getting. What does that figure mean? It is a quadrilateral and it is a trapezium. What does a trapezium means? See, this is the O, A, B, C. Okay, I am getting a trapezium here. Why I am saying it is a trapezium? Because a trapezium is a quadrilateral, is it? And what is the speciality of a trapezium? It is having two lines parallel. Okay, two sides are parallel in a trapezium. See, what are the two sides parallel in this? Let us see. See, OA is the first line. Okay, first side. The second side is AB. Third side is BC. And the fourth side is OC. So, what are the two sides parallel in this? Can you see? OA is parallel to BC. Is it? See, if I draw this is OA, the first part. And the second side is BC. These two are parallel. Is it? So, OA is parallel to BC. And in trapezium, other two sides will not be parallel. As you can see here, AB is never parallel to OC. You can see. Is it? This is the hypotenuse of the triangle and this is the side of a rectangle, and this will not be parallel to each other. Okay. So, this is the trapezium. So, as we have discussed earlier, how to calculate the distance travelled by the body in this graph? You have to calculate the area under velocity time graph. Okay, so we can calculate distance travelled S is equal to area under velocity time graph. Okay, area under velocity time graph. And what is the area under velocity time graph? What's the shape of that? It's a trapezium. So we can write that as is equal to area under equal to area of trapezium what is the name of the trapezium? O, A, B, C. O, A, B, C. Is it? So, we can calculate the distance travelled by using area of the trapezium O, A, B, C. And you can see two figures here in this. Two shapes are there in this trapezium. What are they? One is the triangle and the second one is a rectangle. So when we add the area of the triangle with the area of the rectangle, you will be getting the area of the trapezium, is it? So we can write it as S is equal to area of triangle. What is the name of the triangle? A, B, D. Okay. Area of triangle A, B, D plus area of rectangle. Area of rectangle. Area of rectangle. What's the rectangle's name? O, A, D, C. Okay. I am writing it as O, A, D, C. Okay. So, you all know that how to calculate the area of a rectangle and how to calculate the area of a triangle. You have learned in the smaller classes. What is the area of a triangle? It is half into base into height. Is it? So, let us write that half into base. What is the base here? Base of this triangle. This is the triangle. And what is the base of this? This is the base. What is that? AD. AD into and height of the triangle. This is the triangle. And what is the height of it? It is BD. Okay. So, I am writing it as half into AD into BD. Plus, now we are going to write the area of a rectangle. How to write the area of a rectangle? That is very simple. Length into breadth. Okay. So, here the length is OC and breadth I am taking it as OA. So, OC is the length and OA is the breadth. So, OC into OA. Okay. And here you know that last equation also we have proved that AD is equal to, see, since it is the rectangle, opposite sides are equal, AD is equal to OC is equal to T. Is it? It is the time taken. OC is the time taken. So we can take it as T. AD is equal to OC is equal to T. Okay. Since it's a opposite sides of the rectangle, we can write AD is equal to OC and which is equal to T. Okay. And BD. BD also we have find out in the last equation. That is equal to BD is equal to BC minus OA. Do you remember that? Yes. So, and we have written here BD is equal to V minus U. BD is equal to V minus U. Okay. And what is OA here? OA is equal to U. So, shall we substitute this in this equation? We can write that half instead of AD, that is equal to OC, we can write T into BD is equal to V minus U plus OC. What is OC here? OC is equal to T into OA is equal to U. Okay. So, we can write it as half, let me write V minus U first, into T plus UT. Okay. See, in the last equation, what is the first equation of motion? V is equal to U plus AT. Is it? And V minus U is equal to, from this equation, this is the first equation of motion. From the first equation of motion, we can write V minus U is equal to AT. Is it? So, instead of V minus U, I can substitute another value. What is that? AT. What is AT? Acceleration into time. So, I am substituting that. S is equal to half AT into T plus UT. Okay. So, we are reaching the second equation of motion. So, I am rearranging it. First, I am writing this UT plus half AT into T. T into T is T square. So, we will be getting AT square. So, this is the second equation of motion, which is the position time relation. Hope you understood this. S is equal to, this is the second equation of motion. S is equal to ut plus half at square. What is S here? That is the distance travelled. How to calculate the distance travelled? It is the area under the velocity time graph. See, what is the equation? S is equal to ut plus half at square. Clear? Thank you.